Hello, my name is Jeff. I am an accounting and finance and Excel tutor. So let me solve this problem using Excel. Grandparents contribute into an account at the beginning of each month. An investment pays 8% compounded monthly, and they want the balance to be $150,000 at the end of 18 years. Now, we want to state whether the problem is an ordinary annuity or an annuity due. Well, since the payments happen at the beginning of each period, then this is an annuity due. Payments normally happen at the end of the period, and that's just called an ordinary annuity. And so if the payments happen at the beginning of the period, we call this an annuity due. So let's switch over to Excel and let's solve using Excel because it's going to be a little bit faster. So here's what we know. The periods per year is going to be 12 periods per year. Now for Excel, we need to put a 0 or a 1 to make sure it knows it's an ending balance or a beginning balance. So that's going to be 1 is the beginning. If it happens, the payments happen at the beginning of the period. And then we're going to have the number of periods is going to be 18 years times 12. So that's 216 periods. Now our annual interest rate is 0.08, which corresponds to, just plain old 8%. But remember, as a decimal, it's 0.08. So if we take 8% divided by 12, what is the monthly rate or the periodic rate? It's going to be less than 1%, about 2/3 of 1% every month. And so we can do this. We can look at the periodic rate as 0.666 repeats, right? And so you'll need to use decimals. Now to use the formula, I have the formula over here. We're going to use not the percentage, but just the decimal format. So you need to use, 4 or 5 digits so you can get a good answer without a lot of rounding error. Now the present value is going to be 0. We're going to solve for the payment, and the future value is going to be 150,000. Now you can just plug in the future value is 150. The R is going to be 8% or 0.08 divided by 12, which turns out to be 0.006666 repeats, right? So 1 plus R, we're going to use the periodic rate. N is the number of periods, which is 216. We can solve and get a payment. Well, Excel does this faster. So let's do this. This is actually called the payment function. So the payment function is the rate. We're going to use the periodic rate. The number of periods is going to be 216. The present value is going to be 0. The future value is going to be 150,000. And we want to make sure we put in 1 since the payments happen at the beginning of the period. And so we'll hit done. The answer comes out to be negative, but we can force it to be positive by making a negative. Negative makes it positive. So the answer is $310.37. So that's how you solve a payment if we want to grow and have a balance of 150,000 at the end of 18 years when the payments happen at the beginning of the month and we earn 8% compounded monthly. You can do the formula, but this is the modern way to solve problems using Excel.